Hello all, today we are solving LeetCode problem number 2069 walking robot simulation part 2. So we are given a width cross height grid actually. So there is a grid which is present in the XY plane in the bottom left cell at position 0 0 and the top right cell with width -1 and height -1. So this is the configuration which is being given. So basically we are having a grid in an XY plane and the measurement is given. So the top left is 0 0 and the top right actually, not a bottom right, so top right is with -1 and height -1. So using this we can find the perimeter actually, or the area, whichever is required based on the problem. So the grid is aligned with 4 cardinal directions, which is north, east, south and west. A robot initially starts at 0 0 position facing the direction east. So if we want to visualize this is the given example. So we are having xy plane and the robot is placed at 0 0 position and we have 4 directions given. So the robot can be instructed to move in a specific number of steps. For each steps it does the following: attempts to move forward one cell in the direction it's facing. So initially it is starting with the east direction. So if this robot is moving to is out of bounds, so the robot, if it is moving to out of bound area, then what happens is the robot instant turn 90 degrees counterclockwise and retries the step actually. So what happens is, if for example at this position it is going out of bound, so then what happens is the counterclockwise direction, the anti-clockwise direction, the robot turns 90 degrees. So from east it moves to north and then it retries the moving the next the forward step 1, so the move forward 1. So this is what the action it does actually. So after robot finishes moving the number of steps required, it stops, await the next instruction. So what we have to do is there is nothing required. So based on the move direction we move and we wait until we get the next direction. So now the given task is nothing about solving the complexity. We have to construct the following robot class actually. So this is about something deals with the object oriented programming of handling multiple functions within the particular class. So we have robot constructor, so which initialize the width and height, the grid actually, with robot at 0 0 facing east. So first one is we have to do the constructor part, which initialize the grid and robot with positioning it in east direction and at 0 0 position. So this is all the required for the constructor, and then there is void step. This instruct the robot to move forward in number of steps actually. So this is part 1, and part 2 is void step implementation, so which moves the robots. And then there is another one which is get position function, which returns the position or the current cell actually, so which means current cell exactly. So now get direction, which returns the current direction. So this is what exactly we have to construct it. So now only thing which we need to handle is get direction is simple, get position is simple, because we can use a variable and then we can track it down the position actually. So for position we can use xy coordinates, track it down and return it. And for direction we can use a variable direction variable which will have the current direction of the robot, and then we can return it out. So for void step there is nothing much complex here, because only thing we have to take care is when it is reaching the out of bound area, it has to turn the anti-clockwise 90 degrees. So which means we can hard code it like, if it is east it moves to north, right? So if it is north counterclockwise it moves to west, and west to south, then south to east, so it goes on, right? So this is how the 4 directions we are going to deal it. So Only thing is we have to calculate the perimeter and we have to calculate the width actually. So based on or the out of bound coordinate, and based on that we have to guide it. So this is pretty close to the simulation part. So only thing what I am going to do is I will explain how we are going to handle the step. So we will be given num as the parameter which will give the number of steps taken, I mean number of forward movement which the robot will take. So we have the fixed length which is the perimeter, right? So for example, so based on this example we can consider we have 1 2 3 4 5 6 and 1 2 3 6 8 9 10 11 12 13 14 15. So we have the perimeter as 15 for this actually. So now if n is equal to 15, what happens is we will be ending up in the same position at the starting position, right? So there is no requirement for any movement, and then directly we can return it, right? Return whatever direction it is facing, but this time the direction it will face is south, because we started east. If it is 0 and at 15 it will be landing up this position and facing towards this which is south, right? So now, so this is the part where we have to handle this edge case. So if it is 15 and number if equal to 15, I mean the perimeter equal to 15 and number is 15, we can place it at the same position, but only thing is we have to change the direction. So how do we do that? So we have to measure it actually. So not measure it, we have to modulo this perimeter with a number. So modulo number gives actual steps required. So if it is less than 15, for example 14 modulo 15 is nothing but 14 actually. So if it is 16 greater than 15, 16 modulo 15, which will give us 1. So which means ultimately you have to move one step. So in case of 17, what happens is 17 modulo 15 gives us 2, so we need to move 2 steps actually, so instead of 1 step. So this is how we will deal with the heights actually. So if we want to if for example this is actually about the whole perimeter actually, so there should be the next lock which is or next check, it's not about lock, it should be the next check which is for the movement of x-axis. So if you're moving in the x-axis towards east, what happens is this may be up to a limit 7 for example, and you have num as 15, or let it be something like 23 for example. Then what happens is you can move only 7 steps. So you will move 7 steps, and then remaining 16 step, what happens is you will come to this point and you will move, I mean you will do a 90-degree turn and you will move towards north, right? So this is how you move. So what we do is we will find minimum of this total length which is 7 and the nums actually with the nums added with the x-axis, so based on which we can get the maximum movement in the x-axis. So that we will choose 7 and we will subtract that from num, which means num will be updated back to 16, and then you will carry down the same num in the north direction. So this is all about the simulation. So with this idea of the simulation, let us jump into the coding part so that you can understand better. So yeah, so first we will do the constructor, the initializing part. So we will have x-axis and y-axis. So self dot x is equal to 0 and self dot y is equal to 0. So now we need to have a variable for getting the direction. So self dot direction is equal to east, and then what happens is self dot width is equal to width, which is given here. So width, and self dot height is equal to height. So now this initializing part is done. So let us jump into the direction part, because this will be simple only actually. So we will have to just return the self dot direction variable, which will have the current direction, right? And also for position we should return that in the format of list actually. So based on this, where is it, yeah, so 1 2, so we have to return the position, right? So now we will return, well, I mean we will return here in the list format we will have self dot x and self dot y. So two coordinates is done, so we return the position. So now we have to deal with the main function, which is the step. So we will start with finding the perimeter. So perimeter is equal to 2 multiplied by we have to have the width length, which is given as width minus 1, so minus 1, so this should be self referenced with self. So yes, so width minus 1, and this should be added with 2 into self dot height minus 1. So yeah, so now this is done. So perimeter part is done. So now we have to calculate the num, the total movement actually. So num equal to, modulo equal to peri. So now you will get actual num or actual movement which you have to take, because based on that you will reduce the larger steps, right? So as we discussed. So now this is done. So now we have to check. So if num is equal to 0, then we will return sorry, this will be num is equal to peri. So you update this actually, and then you move for the next step. So because this will have the edge case, so this will be handled at the end. So we have to just alter it, and we have to change the num. So that is it. And now we will handle if we have anything left in the num. So if any value is there, if there is no 0 and if there is some value, then we have to move it, right? So while num is greater than 0, we run this loop. So now we have to handle for direction east. So if self dot direction is equal to east, we will have the logic. So pass, and lf self dot direction is equal to we will have west, it should be north next, pass, and lf self dot direction is equal to north, pass, and else pass. So now these 4 things are done. No, actually, so else this means we will have actually. So this is the the case which we are going to handle, because if it is 0, then it should be pointing towards the other direction, right? So so here we will have one more logic. So lf self dot direction is equal to, this should be equal to south, pass, and yes. So now we will start with this part actually. So yeah, so we will start with the east. So first we will check we will check the maximum x-axis which this can cover. So maximum x is equal to minimum of self dot the x coordinate value plus num, because that is the initial position. So with added with num, and this will be compared with the self dot width minus 1, so because that is the maximum amount which we will get, right? So minus 1. So now you get the maximum width value, and then we will have to find the remaining, which is equal to this num minus this one actually. So maximum x minus the x, right? So this will be num minus you have these two values, which is maximum x plus sorry, this added with minus self dot x. So thus this gives the remaining value, and with remaining value you can proceed it. So if, and you have to update that in the num, because that is what we are using for the next iteration. So num is equal to remaining, and then what you do is you check if remaining is equal to 0. If it is equal to 0, what happens is you will update the x value with the max of x, right? Because that is the coordinate which you store. And else what happens is you mark the direction, because you are moving to the next direction, right? So self dot x is equal to max of x, and else part you are also self dot x is equal to max of x and direction. So direction is updated to north. So these are all the logic which we will use. So now next one is we have to deal with the west. So we will copy the same. Only thing is we have to imagine that, right? So west, moving towards west, the direction is changed. So the starting position will be the width minus 1, and we will be moving towards 0 0, right? So not 0 0, we have some y-axis value, but you can just imagine of that. So which means the thing will be completely changed. So we can just copy and paste it. We will have min of x value, and this will be completely different, because you will have to subtract this value, which is self x minus num, and this should be maximum, because we are starting from the end to, and we are moving towards the 0, right? So max of minus this, and the position which we can reach out is 0. So maximum among any two, this should be the value. And again the remainder is equal to min of x, the num minus min of x minus x. So I think we can bracket this also, yes, just for understanding. And yeah, min of x minus this should be, yeah, self of x minus min of x, right? Yeah, because this will be the higher value, self of x minus min of x. So now we have calculated this, and the similar part which we are going to handle is if remainder is equal to 0. So this should be min of x, and again this should be min of x as well, and the direction will be moving towards south. So now this part is done. So now we are moving to handle the north direction. So here we will have the max, yeah, better, I think we can code it up. So we can have max y value, which is equal to min of self dot y added with the num, right? And the maximum will be height minus 1. So self of y plus num, and min of height minus 1. So this should be referenced by self height minus 1. So now you got the max value, and now remaining value, which is equal to num minus max y, and this should be separated by self dot y. So now this is done. So you have update num is equal to remaining value, and if remaining value is equal to 0, then you update. So self dot y is equal to max y, and else self dot y is again equal to max y, and now you have to change the direction, which is towards west. So self dot direction is equal to west. Yes, so this is done, and we will copy the same thing, and now again you have to repeat the same thing, but again things will get changed. So now you will have min y here. So same thing which we same ideology which we did for west case. So min y and min first let me update this min y with min y. So min y, and the direction will be updated back to east, right? So self dot, yeah, this is done, and number updation is done. And so now what happens is he will have self dot y, and this should be subtracted by num, and it ranges, the maximum value will be 0, sorry, minimum will be 0, and this should be maximum. Yeah, maximum of this, and remaining is equal to number minus self dot y, this should be reversed, minus min of y. So same. So now this is done, so this part is done, so else part is also handled. And yeah, so we do not need this one because we have to have the number, so which with which we are getting it, and the edge cases will be automatically handled. So if it is equal to 0, you will update number is equal to perimeter, and it goes on, right? In terms of if it is perimeter, what happens is you will have the actual value of perimeter passed, which means, for example, here the perimeter is 15, so the 15 will be in place of number, right? And then you continue the iteration and you will end up in a value. So there is no need for handling this special case, that is if it is equal to 0, to change the direction to south. So yes, so let us run it and submit it, and there you go. Thank you.